Atlanta-based aviation firm Hermeus has been hard at work developing a Mach 5 capable passenger aircraft since 2018, and their efforts have not gone unnoticed. Just a few years ago, they secured a $60 million contract from the U.S. Air Force to continue development on their quarter-horse hypersonic tech demonstrator. And now, just about a week ago, they announced the addition of another $100 million in private equity invested into their hypersonic efforts. I sat down with Skyler Shuford, the COO of Hermeus, for an interview that was going to go into a traditional episode of AirPower, and in fact, very likely still will. But the interview was so interesting, I thought it would be better just to upload it in its entirety, so you can hear directly from Skyler what it is that they're up to, and how it just might turn parts of the aviation industry on its ear.
I think what we're doing, if people don't think it's crazy, they should. It's crazy. Like, what we're actually doing is absolutely insane.
Now, this isn't the sort of content that we usually produce, but if you like it, please let me know, and we'll make more stuff like this. Now, without any further ado, let's just dive into the interview with Skyler Shuford, COO of Hermeus. I'm Alex Hollings, and this is a special edition of AirPower.
Yeah, my name is Skyler Shuford, so I'm one of the founders. I'm also the COO. That doesn't really mean too much, but the kind of way I describe my job is, focused really on who we are and how we do things. So that's everything from the external brand, public-facing things, press relations, investor relations, that kind of stuff, to the internal stuff, like process, the systems that we put in place, internal applications development, growth, and culture.
Awesome. Now, obviously, I know the answer to a lot of these questions. I'm going to ask them just so I can get them in your words. Can you sum up for me briefly what it is that Hermeus is doing?
Yeah. So the big picture, long-term vision is to speed up global transportation in a massive way. And we want to do that with Mach 5 aircraft. That seems crazy, but, something that we really believe and have seen throughout the industry is that the component technologies for Mach 5 aircraft exist today. There's still a major challenge in bringing them all together. And I think that's really the innovation that we have here is how do we marry the kind of financial roadmap with the technical roadmap? And the way we're planning to do that is by solving a lot of national security problems for customers, all before flying people. So we're partnered with the Air Force, NASA, as well as some other government agencies to be able to, bring this high-speed technology to bear against some national security problems. And help us kind of learn about the technology before we go to, build a transport aircraft that safely and comfortably flies people.
That makes perfect sense to me. And I understand that's sort of your approach to scaling is starting with an uncrewed prototype and then eventually moving on to crewed aircraft, right?
Exactly. Yep. And really that changes the kind of risk posture that we can take to flight. So something, one of the core kind of foundations of the company is that we have to get to integrated tests quickly. You don't really know something about flying until you've, actually gotten it in the air and, tested it out in a flight-like environment. You can spend a lot of time in the analysis, but, until you're actually flying it and seeing what breaks, you don't really understand it. So, being able to push a lot of that risk into the flight campaign, strategically, we want to, do our diligence on the ground before we get there. But being able to, get into flight quickly without having to, make sure we have the redundancy necessary to keep people safe, gives us a lot more flexibility on getting to flight quickly and really starting to understand where the problems are.
Before I go any further, I want to ask, I know you said that you have some big news that you're going to be releasing soon. Do you want to tell me what it is up front? Do you want to wait till the end and make it a big surprise?
No, we can do it right now. So we're pretty excited. So we closed a $100 million Series B led by Sam Altman, which is pretty great. So we, with that money, we'll be able to get through our entire, prototype campaign with quarter horse, being able to flight test that, multiple tails of that. So that's another part of our strategy where iteration is really super important, where, we're not just building one of these and it has to work. While we don't want to do this kind of recklessly, we are comfortable making a hole in a desert if we have to in the pursuit of learning how to fly at these conditions. So having, the kind of financial backing to be able to build multiple tails. Some of this money will also go towards, future products. So we're not talking too much about those future ones yet, but really starting to lay that kind of financial and technical roadmap that eventually gets us to the transport aircraft long term. Sam has been a great partner for us, and we also have additional support from our current investors, all who have been super supportive. Really interested in these long-term big swing aerospace projects, and have experience in those spaces, which is great. And just being able to have a support system of like very, I think, well-rounded and experienced professionals within the investment space has been great for us.
And obviously shows a great deal about what you guys have already accomplished and just the credibility that you bring to the table. So congratulations.
Yeah, I really appreciate that. And I think, I have to give credit to the team. While what we're doing, it's still pretty early stage. We obviously haven't flown an aircraft yet, but the team is really, really strong. So, and I think Sam and the previous investors really kind of understand and see that. We brought talent from basically every center of excellence in aerospace to bear against this problem. And really it's a pretty interesting culture that we're starting to create here where, people from different organizations that wouldn't necessarily interact. While we do hire a lot from like the SpaceX's and the Rocket Labs and the kind of new space aerospace companies, we're also recruiting a lot from, more traditional centers of excellence that, sometimes within startups may get a bad rap, but, we have some folks from like Sandia that, where they're spending a lot of time working on hypersonics. So we might as well bring some of that expertise in-house, NASA, GE, those type of places. And really just finding the right balance of folks from different areas of aerospace to really, move quickly and build stuff, sometimes break stuff, but be able to, really get to that end goal as quickly as possible and in a more efficient way than I think a lot of people would expect for hypersonics. A lot of times, people say that it's going to cost $1 billion to be able to fly hypersonically. And I think if you de-scope the right things, not having people on board, making something very, very small, additional other sort of, approaches, you can really do something on a relatively shoestring budget when compared with, what people are typically doing in hypersonic, which ends up being hundreds of millions, if not $1 billion.
No, absolutely. I mean, we've seen firsthand with the F-35, obviously not intended to be a hypersonic aircraft, really a flying supercomputer of sorts. But you can really see how iterating a platform can become hugely expensive when you're not that worried about how much you spend at the end of the day, right?
Yeah, I think that's definitely part of it. I think the Air Force is already moving toward a different model of how to acquire these types of, complex systems. F-35 is pretty awesome in terms of the tech that's in there. But I think it's really driving down the logistics tail. And that, basically how long it has to be in service to make sense. So driving to these more inexpensive systems that can be iterated on, you can constantly improve the software on board. You can constantly improve the tech as things like computer chips get better, as different material properties, especially as 3D printing is coming online. Being able to iterate on in-service products is something the Air Force is moving towards, and it's actually really great to see. And I feel like we're in a very good time where a lot of those changes are happening, and the Air Force has been super supportive in our kind of new approach to how to do high-speed aerospace.
That idea of iterating on projects in service is fantastic. I love that. And that kind of leads into another question I have for you, which is, can you explain to me some of the real benefits that hypersonic flight could bring to the defense apparatus? I understand there are huge implications for commercial transport and for passenger transport. What are some of the ways that hypersonic flight could benefit the military in general?
Right. Yeah, absolutely. It's a great question. So I think early on, when we started looking at this, we really thought it was about survivability, which is definitely true. As technology gets better and better, you can pump more and more ground-based power into radars, and stealth really isn't doing as much lifting in terms of survivability as it used to. And so really what that comes down to then is, how to avoid being tracked or hit. And really that's where speed starts to come in. Also altitude to some extent and maneuverability as well. But really where we started to find interest in the kind of intermediate products that we're looking to build is really in covering long distances quickly. And so like when we're getting into, strategic competition, near peer adversaries where we really need to cover long distances quickly. Being able to do so quickly and like get eyes on target very quickly, or reconstitute networks because a comm node went down. Being able to get there quickly, drop off a new comm node. Those are starting to be the more interesting conversations that we're starting to have. Obviously, still a lot of work to do there, and we're not working anything classified yet. At some point, I think it'll probably make sense. But yeah, so kind of the survivability aspect is super important, but also being able to cover the tyranny of distance and reconstitute nodes and find out information to be able to make good decisions in theater.
It's really one of those magic phrases, that tyranny of distance. I wrote an article not long ago about like the current approach to kind of managing that tyranny of distance is a high volume of sort of subsonic platforms. They're talking about trying to put OV-10 Broncos or similar kind of almost World War II-esque platforms to support special operations forces in Africa, for instance. But you could feasibly solve that problem with fewer aircraft if they were fast enough to kind of close the distance that they needed to close, right? Right,
exactly. And I think it really comes down to, though, how many you can put out. And really that comes to price point. So I think, being a lean, small startup, the amount of, overhead or even just the threshold that we need to be able to, start working on these, very difficult problems is a lot smaller than, say, a traditional prime. It's going to require a much larger program to get them to mobilize their internal R&D towards a problem like this, where we can take a little bit smaller of an approach and start moving much more quickly. And with that means, though, that you can kind of reduce some of the requirements. So if it's going to cost $1 billion to build a prototype, that product is going to have to be more survivable. So it's going to have to go faster. You're going to have to put more exquisite stealth on it. You're going to have to put more exquisite systems on it. But with us, if we can reduce that speed, it actually makes it to where we can build it much more inexpensively, and then you can put more out. So it's kind of in this, semi-attritable space where it's not like a tactical system where it's like, like missile systems where it's like pretty inexpensive, relatively speaking. And it's not on the, exquisite side where it's like, what the SR-71 was, where they were a little hesitant to use it because of, one, there's a person on board, and two, just how expensive that platform is. So we're somewhere in between where, if you can build enough of these, you can put a few out. And if you lose one, it's not great, but it's also like not detrimental to the fleet and, the pocketbook.
I think that makes great sense. Kind of the idea of overwhelming air defenses through volume is a lot easier to do than it is to make something that can effectively hide from whatever the air defenses will be for the next 50 years. To your point about that exquisite platform that you spend $1 billion developing, you need to keep that platform in service for the next half century to make it worth it.
Exactly.
And you're trying to compete against the future of defense technology. It makes it really difficult, right? So I suppose in that vein, would you say that like quarter horse and whatever defense application may manifest thereafter maybe falls somewhere between like the Kratos Valkyrie and an F-35? It's certainly not a high-end, high-dollar platform. It's not technically attritable. It's certainly something that you wouldn't want to lose. But feasibly could? Is that sort of where you'd place it?
Exactly. Yep, exactly. So less so quarter horse probably. So really with quarter horse, we didn't put a lot into the requirements. So we wanted that a big part of our approach is to descope kind of ruthlessly to where we can actually get into flight test and do so as inexpensively as possible. So with quarter horse, the only two real requirements are to, basically touch Mach 5 and be reusable. So really for us, it's a flight test platform that proves out our engine architecture, in a flight scenario. So, we're going to be doing some ground wind tunnel testing with the engine, but we really don't know how it's going to perform in flight. There's unstart that we have to be able to maybe even induce intentionally to be able to understand the kind of robustness of the system. But, there are very few requirements. There's, very little that, quarter horse will be able to do operationally. Maybe there's some, and we're definitely chasing down some of those things for productizing quarter horse, especially as a flight test platform in the very least. But really it's the next product that will be on the shoulders of quarter horse where I think it's going to be a big use for the DoD, the intelligence community, and the like.
That leads in to the questions I'd like to ask you about the turbine-based combined cycle engine. Now, Hypersonics, as I know you are aware, as people watching will be aware, tend to come in one of two forms. That right now, hypersonic weapons in particular tend to be boost glide vehicles or scramjet powered cruise missiles. Now, you're kind of aiming to build something that isn't necessarily a scramjet, but could effectively fly in every speed of the flight envelope in one engine, which
Right.
is, it's fair to say nobody has managed to field an operational scramjet yet, but I can only assume the challenges have got to be immense. Can you talk to that a bit?
Yeah, it's definitely hard building a Mach 5 capable aircraft that, takes off on a runway and lands on a runway and, operates efficiently across the, full flight, the full Mach envelope. But, near term, the major primes are focused in weapons and they should be. That's where their expertise is. That's where the major need is. And that's where the budget is. So we're looking a little farther out. We don't want to compete directly with them. So we're looking at kind of the next step. In terms of, the scramjet, eventually I think we might start looking at some of that stuff, but to the point that I made earlier about, de-scoping being a major philosophy that we have here, that's kind of why we chose Mach 5, for one of the reasons. So, at Mach 5, ramjets still close. So we can keep all of the flow in our TBCC subsonic, so that, we can do a lot more inexpensive testing on the ground to be able to get, to a certain level of confidence in it before we go up and fly. It's a similar sort of architecture to the J-58, which flew on the SR-71, in that, we have a turbine and, we have some bypass around that. One major difference, though, is that once we get up to speed, we will fully shut down the turbine and go purely ramjet. So the J-58 didn't fully shut down the turbo machinery, which actually led to some more significant challenges. They had to use different fuels for cooling, the turbo machinery, because it was still running at these really high temperatures. But by shutting it down fully, we can take advantage of the kind of being able to fully decouple those systems. And, for a subsonic flow path, a ramjet combustor and an afterburner are very similar. And so that's the ram burner that is similar to the J-58 will be utilized on our Chimera engine that will serve for quarter horse.
That's awesome. And bringing up the SR-71 is a great example of kind of what you mean with that survivability. The SR-71 outran something like 4,000 missiles in its career, kind of just by leaning into the throttle. And I think that's really what we'd be looking at with a Mach 5 platform in this day and age. Obviously, surface-to-air missiles are getting more advanced by the day, but trying to hit something moving at Mach 5, this is part of the challenge that we're talking about with hypersonic weapon defense, is that something that's maneuverable and moving at 3,300 miles per hour is very difficult to try to intercept. It's not shooting a bullet with a bullet, it's shooting a maneuvering bullet with a bullet.
Right. Absolutely. Yeah. It really comes down to kind of total energy expended. So altitude actually plays a major role in this as well. It's not just speed. And we kind of have to fly high because the heating and basically the dynamic pressure, the load on the vehicle caused by speed, that really, we have to go higher. So, being able to fly high and fast in a maneuverable way does add a lot to survivability. But surface-to-air missiles, to your point, are getting better, and it's a lot easier to test those systems and build them. So it's not the magic bullet that it once was. So that's why bringing the cost down is actually a major knob in total system survivability. So if you're looking at like a swarm of these, it's a lot different in terms of obtaining your objective than it would be if you just had one and it had to work, and that one is the only one you have.
I mean, we saw that with the D-21 during the Cold War. It was in some ways sort of similar to Quarter Horse in that it was a supersonic drone of sorts. Really kind of looked like you hacked the wing off of the SR-71 and put some cameras on it. But it didn't prove to be all that effective, in large part because it was just ludicrously expensive, not just to build, but to operate,
Yeah. So D-21 is actually a great analogy. So effectively, it's about the same scale as Quarter Horse and a similar type of mission that is a possible outcome for Quarter Horse. But D-21 being a pure, ramjet that was air launched, but in terms of scale, about the same as Quarter Horse. And we see a lot of similarities in how we might want to use that Quarter Horse aircraft. But yeah, so I think they sold something like nearly 40 of those aircraft at like 40 million. But at the time, it was still, they had to, toss off a magnetic tape for the data that it acquired. So we've come a long way in terms of networking and being able to get data from these type of systems. So given that how operationally difficult D21 was to fly, it's actually pretty incredible that they made 40 of them for an expendable vehicle that, you have one shot at it and then throw some magnetic tape out the back at really high temperatures and really high speeds. So, but yeah, that's a really cool aircraft that I'm actually impressed that you knew about, because not a lot of people do.
I sit around in this room 13 hours a day just reading about airplanes. I wanted to ask, so when you secured your contract with the Air Force last year or the year prior, part of the agreement was that they're going to kind of reassess you in 3 years. And at the time, you guys were talking about Quarter Horse potentially making its first flight in 2022. Are we still kind of looking at that timeline?
Yeah, so we're in late stage design. We're starting to cut parts on it right now. So will it be flying in the air at the end of 2022? Probably not. But in 2023 is the meat of our flight test campaign. And as I mentioned earlier, we're building 3 tails with that. So it's not just the first one that we're looking to. It's really with that iterative approach, getting to the Mach 5 conditions with the third tail, with some optionality in between. So while our entire team has been in aerospace development or be in aircraft airworthiness, throughout most of their careers, we haven't done it as a team. So the first tail of Quarter Horse will be a de-scoped version so that we can get into flight and learn how to fly airplanes as a company. And then the later tails will have a lot of those changes rolled in. So tail 2 will be slightly shifted. It won't be a full serial development. There will be some parallelization, but being able to make modifications to later tail numbers, block upgrading the system, is similar to the approach that SpaceX is taking with Starship, although at a much smaller scale, because we don't have the same sort of budgets that SpaceX does with Starship. But that iterative approach, I think, really enables being able to fine tune the aircraft before you have all of the uncertainties brought down, and you can only bring them down so much with ground-based wind tunnels and CFD.
Speaking of that iterative approach and eventually moving towards crewed platforms, what kind of challenges do you foresee with having a pilot aboard an aircraft that's moving at Mach 5, especially when it comes to maneuvering? I'd imagine the pilot's going to be a limiting factor effectively for the performance of the aircraft at that point. What types of challenges would the pilot be facing? Is it something that's even feasible, I guess, to make like a tactical aircraft that moves at these speeds with a sack of meat in it? Or would a crewed aircraft have to kind of be a reconnaissance platform more so than tactical?
Yeah, no, I think it definitely can make sense. Even today's aircraft have stability augmentation systems on them. And so with that, assuming that you design the system right, you can wrap the dynamics and performance around that you want for a certain pilot feel. It's not, direct control that you're going to have with like a subsonic small, Cessna plane where it's like you're actually changing the elevator surfaces or something like that. So there will be a layer of software in between, but that's how most airliners already fly. Especially even, one step above that with adding autopilots to it, it'll be the same type of thing. We're not going to try to, when we start developing the passenger aircraft, we're not going to try and change regulations on having a pilot on board. There will be enough new regulations that we're going to have to help, guide the FAA and get their experience to build. There haven't been titanium airframes that have been certified by the FAA for commercial flight, right? Ramjets haven't been certified. So there's going to be new regulation that has to be made. But we will have a lot of the data from the flight testing and operational flight systems that we've already flown. But in terms of pilots on board, we'll still do the 2-pilot standard. And then at some point, I think the whole industry is moving away from that anyway. We just don't have to lead it. So at some point, having an AI or some even just kind of algorithmic autopilot sitting next to the pilot in like shadow mode until we build comfort, eventually pulling the pilot to the ground. And then eventually at some point, maybe having, a cohort of pilots managing a fleet. If something goes wrong, they kind of focus their attention. There are some interesting games that we could play as we start looking into the future. But it's not something that we're putting in our critical path to getting to commercial flight.
I just love that idea. I just think that's rad. That's awesome. I've run through most of my questions. I want to emphasize one more thing, though, just to make sure that the audience ends up really getting to hear it. You guys really are. I mean, we are talking about, 160, $200 million that you guys have put into this. But when we talk about hypersonic programs with the DoD, I mean, the DoD put 2.8 billion into hypersonics this year alone. And they're developing hypersonic weapons, not reusable platforms, that largely leverage rockets to take them to altitude and get them to speed before using another form of propulsion, whether it's glide vehicle or a scramjet. You're effectively trying to solve 3 or 4 different problems at once for exponentially less money than what the DoD is doing. And I think it's important that people recognize that. So can you talk a little bit about just how you guys have managed to develop a concept that could feasibly work for significantly less than maybe the DoD is throwing into the conventional prompt strike weapon? I don't want to pit you against the DoD in this, but just the idea that what you're doing is something that's literally never been done before, and you're doing it for really cheap.
Yeah. I think there's a few things there. I think what New Space has shown is that vertical integration really actually does help keep costs down. So it seems like you would want to, leverage systems that are already operational and feasible, but especially as you start to get into really, really complex and extreme environments, the system can't be decoupled easily. So with us, the inlet is the airframe and the inlet is the propulsion system, right? It's so coupled. You can't kind of like have multiple suppliers of, engines for the full thing. We are utilizing some off-the-shelf technologies early on data acquisition, the J85, which serves as the turbojet core for our turbine-based combined cycle. So we are using off-the-shelf things that are well-defined. But for new development, vertical integration, I think is a prerequisite, really, because you have to couple everything together and every system has to be talking to them. So what happens is, if you have a traditional way of acquiring new systems, if you have different groups managing major components like the booster for a boost glide system, the flow path for the boost glide for the deployed payload, the airframe, and then have a final integrator. You're adding a lot of inefficiency in the communication between those systems, and so changes take a long time to roll into the system, and sometimes they don't at all, and you have to take a performance hit. So being able to tighten the development cycle and have all the teams talking to each other brings costs down a lot. Labor is a major kind of portion of that. And I think I think people would understand that, but I think it's even more so than most folks would understand. So really being able to keep the system very coupled allows us to bring costs down. And I think, there is an aspect of like, when you can move fast and do things that are really hard, and you have, the support of a strong investment team, and you're starting to build products for customers and start telling that story, I think it's like a really exciting place to be, where there's a lot of really hungry, motivated, intelligent folks who want to be doing that on really tight design cycles, and where, they're highly accountable to the outcome. We can really recruit a lot of really, really talented engineers and even the broader team, on the operations side, to be able to support this, where it's just really exciting. So, and it's a fun environment to be in. So, for one example of like how do we do this, in our after we raised seed funding, we had a team of about 8 people, and we built out a subscale prototype of this engine. So, I'll reiterate how much de-scoping is important to us, but we were able to build a prototype of the engine subscale for $1.5 million and a team of 8 people in only 9 months. That we took an off-the-shelf small jet engine, we pushed it up to Mach 3.3 temperature conditions in a wind tunnel, and then took our shared afterburner ramjet combustor and tested that at about Mach 2.8 conditions and pushed it all the way up to about Mach 4.2. Which was the facility temperature limit, but all the hardware looked good and was operational. So we proved out the entire architecture in it for cost and a number of people that people would probably say are impossible. There are similar programs that that have been out there where it was 1 to 2 orders of magnitude more expensive and numbers of people. So, now there's still a lot more to prove out, and that's what we're looking to do in the next phase. But, we really feel confident in the architecture and with the team that we have to be able to do it.
It really does sort of feel like this is almost two stories. One is the quarter horse and Chimera, and the other one is sort of this new approach to building platforms quickly and effectively, as opposed to, I mean, for a long time we were relegated to doing things slowly just because we couldn't use computer modeling and stuff. But it almost seems as though we're at a pivot point in sort of how aviation works. Which brings me to, I suppose, what my last question would be for you, and that's, what's the future look like for Hermeus? What have you guys got coming up ahead, and what do you anticipate are some big milestones that we can expect to see?
Absolutely, yeah. I think even beyond aviation, aerospace in general has seen these sort of upheavals. I think it actually first started in satellites. I mean, as it used to be giant buses that were going up to geostationary orbit. Massive multi-billion-dollar or even high hundreds of millions of dollars for like weather satellites. But we saw a change where things started getting smaller, CubeSat started coming online, and even now some like mid-sized ones with Starlink. But like the ability to iterate on those projects is what has kind of led to a resurgence in the kind of satellite technology. We saw the same thing in launch vehicles. So I think Hermeus is really, I would say, one of the forefronts on especially high-speed travel, but aviation in general. We're the new space approach to aviation. I'm still trying to figure out the words of new space is such a great term, but it doesn't really apply to us. So maybe new flight. If your audience has great ideas, we would be happy to kind of add that. We're seeing the sort of same thing in electric vehicles and electric aviation. So really excited to see kind of how the industry is evolving toward this more aggressive kind of private capital-based, but still, working with DoD as it makes sense, and really driving toward commercial products as quickly as possible. I'm really excited to see where that happens. In terms of what Hermeus is doing, really exciting stuff. So right now we have our Chimera engine, which will go on quarter horse on the test stand right now. We're looking to really characterize all the nuances of that system and make sure that we, checked all the boxes and found all the corner cases. The next step then is, completing integration and build of the quarter horse vehicle, that first tail. So being able to do a lot of ground testing on that. We're moving very fast on that at our facility out here in Atlanta. And then, getting into flight tests with quarter horse. We're still keeping an eye to the future though, and starting to build out, what is that next product, what does that next product need to do to really solve problems for customers? And so for us, that next product we're calling Dark Horse. We're not really releasing any details around that, but that is really the operational product that will allow us to start understanding not only what customer needs are, but like the maintenance, repair, and operations of aircraft like these, which will help inform, what we need to go do for transport. If we tried to go and build a, 20-passenger Mach 5 capable aircraft for passengers, I think it'd be a bit naive. So we really need to understand these flight conditions, and that's what the roadmap going forward looks like. It's like, how do we create products that allow us to de-risk the tech for that big picture long-term vision?
You very well might end up creating a hypersonic gold rush as a result, right?
I'm certain that there will be many lookalike companies that start popping up once we get into flight testing. It happened, in satellites, it happened with rockets. So as frustrating as that is because they'll probably raise a lot more money than us because there's a proof of concept out there. It also is pretty cool that we're kind of like carving that trail.
Yeah, that's really, really cool. I couldn't be more excited about what it is that you guys are doing. I've been covering aviation for some time. To a certain extent, we've been sort of covering the same, 11 aircraft that the U.S. has been operating, the U.S. military has been operating since, the 50s in some cases, the 70s often. So it's really exciting to be in this era where we're seeing dramatic changes. It's almost like the stealth revolution in the 90s, where all of a sudden things just started looking dramatically different.
Oh, yeah, we're hoping that's definitely the case. I think, there's a resurgence where people want to do things like the original way of like Skunk Works in the Apollo era. I think there's something, kind of glorified, and that was somewhat the golden era of aerospace. Our CTO, Glenn Case, he always says, when he was coming up through school, he thought he was born in the wrong decade because, all the great things had really happened, like, jet engines, rockets, ramjets had all been kind of, basically solved to some extent. But I think that this might be the platinum era, in that, we're bringing a lot of private capital to these dual use technologies, which is creating a lot of interest. And I think there are a lot of folks who go work on rockets and, go to these new space companies, but really want to work on airplanes. And so this is like a new way for them to, be a part of these, growing, exciting industries for the thing that brought them into aerospace in the first place, which was airplanes and high-speed aircraft and like SR-71 and, those type of airplanes, or X-15. Being able to like work on the modern equivalent of that, I think is really exciting. And, we have a lot of need for people to come join the team. So hopefully this definitely creates a lot of excitement, and we can have a larger team that helps us to manifest this vision. I think what we're doing, if people don't think it's crazy, they should. It's crazy. Like, what we're actually doing is absolutely insane. But I think the way that we manage that is by incrementally approaching problems. And I want to reemphasize that it's not like we're trying to go out and raise, $5 billion to go build a transport aircraft. We really are, crawl, walk, running our way into these things. And, and in a way that marries the financial roadmap with the technical roadmap. It is hard. Building a Mach 5 airplane, turns out it's hard. Who would have thought? But, it's really about having a team like with a shared vision that, obviously there has to be a lot of talent, but there also has to be a lot of hustle. And, but really we're trying to build a tight-knit team that is excited to work together. I think the energy that the team has is pretty incredible. We were pretty intentional about putting together a diverse set of perspectives on, from different places within aerospace, from people from different backgrounds, people with different personalities. And I think it's pretty incredible. There's different personalities on the team that I think would never have ever been friends in real life. But there's something interesting that's kind of happening here that I think is pretty exciting. So happy to, get the message out there and really have people start getting excited about what we're doing and help us on our journey.